Hello guys, we have learned in the previous chapter, that is matrices, every algebraic a pair of algebraic equations can be expressed in terms of matrices. It can be written in the form of matrices, whether it is two equations or three equations we can write. Like for example, you have a1x plus b1y is equal to c1, a2x plus b2y is equal to c2. I can write this two equations in the form of matrices like this. I shall call that as ax is equal to b. I am directly jumping into the way of matrices attached to this new chapter. Okay, I am telling you about the new chapter now. So now we have learned like this, that the two algebraic equations can be expressed in terms of matrices. It's like this. We have the coefficients of the variables here. There are two variables x and y, and the coefficients of these variables can be written as one matrix, and that's called as coefficient matrix. It will be a1 b1 a2 b2. This is a coefficient matrix. Next I shall take this variable matrix x and y as a column matrix, because after multiplying this I should be able to get the equations back. Is equal to, what is your B? It is a constant matrix which is C1, C2. It's like this. Now you see, if you do the multiplication of matrices of these two matrices equated to this matrix, will give back these equations to you. So a1x plus b1y is equal to c2, second row first column. a2x plus b2y is equal to c2. You will get back the equation. So we have learned that these kind of matrices are possible because of the given equations. Now we are stepping into a chapter called as determinant. You know, this is one of the finest chapter where you can learn that so many things can happen, unique things can happen in orderly arranged numbers. Now this matrix, any kind of matrix, a square matrix, of course, any ordered square matrix can be related to one particular number, a unique real number, which is called as determinant. Now this kind of taking out expansion of the determinant you have already learnt as a shortcut method in the previous chapter when we were doing inverse of a matrix by elementary operations. I had made you learn it. So now I will make you recall that. So we have example, the second order matrix, like 1, 2, 3, 4. I had given you a shortcut to find out the inverse of such matrix, and it went like this. A inverse is equal to 1 by determinant A into adjoint A. That is 1 by, what is determinant A? 4 ones are 4. First I will multiply the PD elements. So 4 ones are 4 minus the other diagonal elements, 3 twos are 6, into adjoint. I had told you there is a shortcut, like interchange these two elements, 1 and 4, 4, 1 comes here, 2 and 3 with the opposite signs written, it will be minus 2, minus 3. So the the inverse of this matrix A inverse is given to be 1 by minus 2 into 4 minus 2 minus 3, 1. This was the inverse we had learnt. Now in this chapter, which is called as determinants, we are going to learn how all these came, and this determinant is what is called as the attachment of one matrix to a unique number, which is called as determinant. So this is the determinant. So how are we taking out the determinant? That is where we are starting from this in this chapter. So in this chapter you are going to learn the unique properties of a determinant and how to expand the determinant of a second order matrix or third order matrix, and how are these determinants useful in solving a bigger determinants problems using the properties. And also there are certain equations where I have to find out the values of x, y, z. You know, solving simultaneous equations, second order, two equations if I give you, you will solve it simultaneously to find out the value of the variables x and y inside that. Similarly, there is another method in determinants where we can find out the value of x and y using determinants method. So now we are stepping into the chapter which is called as determinants. So now let us see what is the determinant of a matrix. Okay, here goes the determinant definition. Determinant of a matrix A is equal to Aij. Matrix is always denoted like this, what you had learnt in the previous class. Aij, in the previous chapter itself. Aij is a value to which the matrix is a real value, I'll tell, is a real value to which the matrix A is associated. So every matrix is associated with a real number. So that is determinant is given by, this determinant is given by the symbol delta, and this delta, so delta is a function from what? From every matrix to the set of real numbers. Delta is a function from matrix. So second order matrix, from what kind of matrix? That to a square matrix. Determinant of a square matrix. Yeah, this word was important. Of a square matrix is a function which is from the set of matrices to the set of real numbers. So this matrix can also be, therefore I can write delta is a function from M to R. I wrote like this so that you understand that it is a matrices. All the set of matrices are given by the capital letter M. So now we are learning determinant of a second order matrix, and indeed you have already learned determinant of a second order matrix. Of a second order matrix. This is a procedure which has not been derived, but it has been universally accepted, which is like an axiom. And following this procedure of the determinant, the way we take out the numbers, value of the matrix, this has been accepted universally because it has unique properties in its own way, and these properties are named as properties of determinants, for which we will be using in solving the problems. So determinant of second order matrix, if A is equal to A, B, C, D, then its determinant delta, or determinant of A is given by AD minus BC. Principal diagonal elements product minus the other diagonal elements product. So delta determinant A is equal to AD minus BC, which is also called as delta A. And this determinant not only for second order, we also can take out for third order matrix. But basically the very basic determinant value is always for the second order. Every time we round off to second order matrix to find out the determinant, even in a third order matrix. So let us go to the determinant of a third order matrix. Before that, let me give you an example for this, and I am giving only one example because A is equal to minus 1, 0, 2, 3. So delta A or determinant A is equal to minus 1 into 3 is minus 3, minus 2 into 0 is 0, which is equal to minus 3. So determinant value can be anything depending upon the elements that the matrix has. If the matrix is having complex number or trigonometric elements, then even the determinant value will be based on those particular formulae. So now let us go to determinant of a third order matrix. We will go to determinant of a third order matrix. Third order in the sense it will have 9 elements. It's a 3 cross 3 matrix. Now I shall give you the procedure, and let us be quick in learning this, because these are all some very basic things which we use to do the problems. In that, every problem will be having this determinant, so we get used to it. So I'll tell you the procedure, be quick along with me. If A is equal to matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. You have the matrix like this, and let us start the determinant A. It is supposed to be like this. Determinant A will be taken out again based on the second order matrix only. So how to take the second order every time? So what I use is, this determinant A can be expanded in any row or any column. Okay, so now you see, I can use row number 1 and expand this determinant. I can use row number 2, I can use row number 3, or I can use along column 1, column 2, column 3. So there are totally 3 into 3, 9 methods of finding out the determinant. So now the beautiful thing here is, however, whichever column you use, whichever row you use, you end up getting the same number. So I shall give you an example for that. But even before that, how to expand the determinant in row number 1, I shall tell you. I shall use the row number 1. So we say we are expanding determinant along row number 1. Row number 1, first element A11 I shall take, and I shall multiply this number by the determinant of the second order matrix which is left out after deleting first row and first column. So if I can tell you in a simple way, where A11 is present, that row and that column you neglect and take out the determinant of the remaining 4 elements, which will form a second order determinant. So I told you the foundation is the second order determinant only. So I have taken A11. A11 is in first row and first column. So delete first row and first column. You are left out with this determinant, which is determinant of what? A22, A23, A32, A33. And continuing this procedure in the same manner, I use the first element of the first row. Next I shall use the second element, but the second element I shall take minus A12. I shall take with the opposite sign. Why should I take opposite sign? Again, it will be cleared out after this determinant expansion. There is another reason for this. Okay, so minus, I am taking the middle element with the opposite sign, minus A12 into, now again this A12 is present in first row and second column. So delete first row and the second column, and the remaining elements will be these 4, which will be the determinant of A21, A23, A31, A33. And again continuing, next I shall take row number 1's third element, which is plus A13 into determinant of, wherever A13 is present, that column and that row you delete. The remaining 4 elements I shall take A21, A22, A31, A32 determinant. So this shall give you this expansion, and simplification of this will give you the determinant value of this matrix. Now this is called as the expansion of the determinant along row number 1. Now there is certain property. See, for A11 I have taken plus, and for A12 I have taken negative sign, and for A13 I have taken positive sign. Why is it like this? There is a certain rule for this to take minus. So I shall write here sign convention. Sign convention to expand the determinant. This is, it's like this. In the determinant, I shall take, this place will have plus, this place will have minus, this place will have plus, minus, plus, minus, plus, minus, plus. And just because it is alternative plus and minus, you can't take the way you want. You cannot start from minus here. This place cannot have minus, or this place cannot have plus. Now why is it like this? What is it based on? This is based on the formula minus 1 to the power of I plus j. So the sign convention of this determinant places will be, the place signs will be equal to minus 1 raised to the power of I plus j. Now what does that say? See, this is A11. See, A11, this place I have given plus sign. Why have I given plus sign? The I value is 1, the j value is 1. So go plug here. 1 plus 1 gives you 2, minus 1 whole square will be plus. So now this place will have minus 1 to the power of, this is A11, this is A12. I shall use 1 and 2 now. So use I as 1 and j as 2. This will be minus 1 whole raised to the power of 3, which is equal to minus 1. Minus multiplied 3 times, you get minus. Similarly, this will be, what is the place value of this? The name of this place will be A31, this will be A32. So minus 1 to the power of 3 plus 2. Minus multiplied 5 times will give you minus 1. So that's also equal to minus, and that is how we have got this sign convention, which is plus minus plus minus plus minus. So you can remember that the diamond shaped places, these places will have minus and the rest all will have plus. So when I am expanding along row number 1, I shall take this place as negative sign. When I am expanding along row number 2, I shall take this as minus A21, this as minus A23, because these two will have the same signs. Now this fetches you the determinant value, which is also given by what? Delta A. Now delta A, this was along row number 1. Along row number 1. So now delta A, if I say along row number 2, along row number 2, how will that be? I shall take row number 2 element A21, which is having what sign? It is having minus sign. So minus A21, and wherever A21 is present, A21, that particular column and that particular row you delete. The remaining elements I shall take, and that will be determinant of A12, A13, A32, A33. Further, I will move in the next element of R2, that is A22, that will have plus sign, like this. So A22, and wherever A22, second row, second column, I will delete and take out the rest determinant. So this will be the determinant of these 4 elements, that is A11, A13, A31, A33. I will push on to the next element, and that will have the negative sign. This place will have negative sign, minus A23 into deleting second row and third column. We get these 4 elements, and that will be A11, A12, A31, A32's determinant. Now all this simplified will give you the same determinant value what you get in this way. So totally how many ways there are to find out the determinant of a matrix? If I give you a third order matrix, there are 9 3 rows. I am sorry, this is not 9, I am sorry. There are 3 rows and 3 columns. There are 6 different ways of taking out the determinant. So now let us find out, we will go for one certain example where I can find out the determinant value in say along a column and along 2 rows or something like that. Yes, I shall repeat once again, there are 6 ways of taking out the determinant, not the 9. I had taken 3 threes. Okay, so now I shall go to one example. I shall say delta is equal to determinant of, and please make a difference. One more note point is, I had given you, if A is equal to the matrix, this is the matrix, then delta A is equal to, if I can write like this. But directly if I give you like this, this delta is equal to, this indicates it is determinant. The straight lines, straight 2 vertical lines will give you the determinant, and this indicate, the square brackets indicates what? It is matrix. So when you are writing your question or your solution, when you are using the matrices or the determinants in between, be particular about the kind of lines and the brackets you use. The brackets will be for matrix and the vertical lines will be for the determinant. There are many methods where if there are continuously usage of determinants and you use matrix there, you lose some marks. Okay, if delta is equal to, I shall take like this, 1 minus 1, 2, some simple numbers I shall take. I shall not take 0 so that you understand properly. 3 minus 5, 4, 1, 2, 1. I have taken a very simple one. And now I shall start along row number 1. Along row number 1, I shall take out the determinant. I shall take row number 1, 1 into determinant of. Wherever 1 is present, you delete that particular row and column and you take out the determinant of this. Minus 5, 4, 2, 1. This place had plus, and so it is having plus. Now this place will have minus, so I shall take the opposite sign. Minus 1 I shall write as plus 1. Plus 1 into determinant of 1 is present in the first row and the second column. Deleting that, I shall take the determinant of 3, 4, 1, 1. Next, I shall take the next element with the positive sign. This having positive sign, so plus 2 into determinant of these 4 elements, that is 3 minus 5, 1, 2. This will be equal to, so I am getting delta is equal to, what we are doing is delta along R1. So delta is equal to 1 into, I shall not use my 1, and I shall take out the determinant, minus 5 minus 2 4s are 8. Now I am already continuing with third order, assuming that you have already got used to the second order determinant. Plus 1 into, again 1 is there, I shall not write anything. PD elements multiplication here 3 minus 1 4s are 4, plus 2 into 3 2s are 6, minus of minus plus 5, 1 5s are 5, and we shall simplify this. This is equal to minus 8 minus 5 is minus 13, 3 minus 4 is minus 1, 6 plus 5 is 11, 2s are 22. So what have you got? It is 22 minus 1 is, it's like this, minus 14 and plus 22. So 12 minus 4 is 8. This is plus 8 is equal to plus 8. Okay, so now let us go to delta along, okay, I taught you along R2, I shall take R2, then we shall do along column number 1 also, column number 1 or column number 2, something like that. See, when I come to row number 2, delta is equal to row number 2 elements, these place values will have minus sign, is it not? So I shall take these elements with opposite sign, minus 3 into determinant of, now minus 3 into wherever 3 is there, that row and that column you delete, then I'll have these 4 elements, that is minus 1 2 2 1. After 3, next I shall take minus 5, this should be written as it is because that place will have plus sign, minus 5 into this column and this row you leave, so you have 1 minus 2, okay, 1 2 and 1 1, and then the next element I have taken minus 5. Now this also I should take with the opposite sign because that place will have minus, minus 4 into wherever 4 is, that column and that row if you leave, you have 1 minus 1 1 2, 1 minus 1 1 2. So let us expand. So delta is equal to minus 3 into minus 1 minus 4 minus 1 minus 4 minus 5 into 1 minus 2 minus 4 into 2 plus 1. So let us see what is this equal to. It's equal to minus 1 minus 4 is minus 5 into minus 3 is plus 15, 1 minus 2 is minus 1, minus 1 into minus 5 is plus 5, and then 2 plus 1 is 3, 3 into minus 4 is minus 12. So this is 15 plus 5, 20, 20 minus 12 is equal to 8. Now don't you think this is so amazing that there is one particular method where following that particular rule you are getting, however you do the addition and subtraction here, you are getting 8 with the following that particular rule. Now like this, there are 3 rows and 3 columns. Along any row, along any column, you follow the procedure. You follow this particular procedure of taking out the determinant. You always end up getting 8 only for this determinant. Isn't it as amazing? So there were persons who found out this method, which is really difficult. Because how can we start up and find out that playing with the numbers you can find out like this for one set of numbers which is put in some rows and columns. So now let us find out if it is true with column number 2. I shall take delta along column number 2, along C2. Along C2. So now I will take column number 2 like this. When I go to the sign convention, this will have minus, this will have plus, and this will have minus. So again, minus 1 I shall write as plus 1. So 1 into, and I shall take out the determinant directly, children. Delta is equal to 1 into. Wherever this 1 is present, I shall delete that column and that row and take out the determinant of this. This will be 3 minus 4. So this will be 3 minus 4. Next I shall go to the next element in column number 2. Minus 5 I shall write as it is because that place will have plus sign. Minus 5 wherever it is, that row, that column and that row I shall delete, though you get these elements. 1 minus 2. So this is 1 minus 2, and the next element I have to write with the opposite sign, minus 2 into. So 2's row and column I shall delete. Wherever 2 is present, this row and this column, then you will get these elements. 4 ones are 4, 3 twos are 6. So it is 4 minus 6. 4 minus 6. Now I should get what? I should be getting this element, this number 8 itself I have to get. So delta is equal to 3 minus 4 minus 1 into 1 is minus 1. 1 minus 2 is minus 1. Minus 1 into minus 5 is plus 5. And 4 minus 6 is minus 2 into minus 2 is plus 4. See, amazingly, 5 plus 4, 9 minus 1, this is equal to 8. Every time we get 8. So there is a set of procedure which we have to follow, and we get the same number. You expand it in any row or any column, you are getting the same number. This is called as the determinant value. So like this, every square matrix is attached to, it is associated to one real number which is called as the determinant value, and this determinant should always be expressed in vertical lines. And it is also given by uh, what, double line. In old mathematics they used double line. If they use double line, it is matrix. If they use single line, it is determinant. So now it is standard way of expressing determinant in vertical lines only, that is single vertical lines. So let us keep it as a standard way what is used in your textbook also. This is this determinant is always denoted by delta A, or it is denoted by with the vertical lines with A in between, and all the elements are enclosed in vertical lines only, straight lines. Now these way of taking out the determinant value, I told there are 6 different ways. And with this determinants, again there are several properties. Again you have unique properties. Whether you transpose and take also, you get the same determinant value. That is the first property. So there are certain properties under determinant. We have 8 to 9 properties to learn about this determinant. But even before that, let us finish something about all the problems from your simple problems from your exercise. You have exercise 4.1, and I shall take here and there few problems. See, you have exercise 4.1. In exercise 4.1, the very first problem is determinant of 2, 4, minus 5, minus 1. We will do directly. 2 into minus 1 is minus 2 minus 5 into 4 is minus 20. This will become plus 20. So 20 minus 2 is 18. Second order matrix, and I am sure that you are already thorough with that. Now let us go to the second problem, where you have the first one with trigonometric functions. Cos theta minus sin theta, cos theta, and you have a sub question number 2 in this, which tells x square minus x plus 1 into x minus 1, x plus 1 and x plus 1. Okay, so this is equal to product of the PD elements will give you cos square theta minus of minus sin square theta makes us as plus sin square theta. So I told you, whenever trigonometric functions or any other complex numbers are used, that particular complex numbers properties, like for properties of omega or properties of I, you can use. Similarly, when it comes to trigonometric functions, we can use the identities and other laws, whatever you get. You may get sin A cos B also, transformation formulae or the trigonometric identities. Here I have got one of the identities. What is that I have got? I have got cos square theta plus sin square theta, as you all know, which is equal to 1. So the determinant value is 1. Let's go to the next determinant. This also, you have algebraic formula here. Can you identify? Before that, let us multiply. I shall multiply the PD elements, then it gives you x square minus x plus 1 into x plus 1 minus, I will multiply these two, that is x plus 1 into x minus 1. What do you find? So this is a formula. Is this a formula? X square minus x plus 1 into x plus 1. Is it the formula? See, this is in the form of a square minus ab plus b square into a plus b. This is in the form of a plus b into a minus b. What is this equal to? A plus b into, this is nothing but a cube minus b cube. And what is this? This is a square minus b square. Okay, so if I use that for this particular expansion, what are you getting? So this so determinants problems is inclusive of all the algebraic formulae, transformation formulae, or any properties under complex numbers. So coming here, this I'll write, this is x minus 1 whole cube, I'm sorry, x cube minus 1 cube minus of a plus b into a minus b will be a square minus b square x square minus 1. I shall expand. So you have x cube minus 1 minus x squared plus 1, minus 1 plus 1 is gone, and you got x cube minus x square, which can be written as x square into x minus 1. This is the answer. Okay, and now let us get into the there is one particular formula in taking out the second order determinant. I shall show you with example and the formula, which is very important for your JEE examinations also. It will be incorporated in bigger problems. See now, for example, if A is equal to 1, 2, 3, 4, I want you to find out determinant of 2 times A, determinant of 3 times A. So, I shall multiply this as 2A first I shall take out. 2 times A means it is scalar multiplication of a matrix by an element, which means that every element of the matrix should be multiplied by that number. When I multiply this matrix A with the number, two multiples of all these numbers will give you 2, 4, 6, 8. And now I shall take out determinant of 2A, implies determinant of 2 times A. This itself is 2 times A, and I shall take out the determinant. 8 2s are 16 minus 6 4s are 24. 16 minus 24 is minus 8. Okay. Now there is another way of doing. I shall take out what 2 in determinant. Whenever I am taking out determinant, anything common, you know, every row you have to take out. So I shall give you directly the formula. 2 power order into, I shall take like this, determinant of 2A is equal to 2 power order into determinant A. 2 power, what is the order of this matrix? It is second order matrix, so I shall take 2 square into determinant A. What is your determinant A? Determinant A is here, 4 1s are 4 minus 3 2s are 6. So 2 square is 4, 4 minus 6 is minus 2, and you got minus 8. So what you can see is determinant of 2A is equal to 2 square into determinant A. Okay, 2 square, 2 per order is 2 square into determinant A. This is what I wanted to tell you. 2 power order you have got. Order is, if I am denoting by n, so then now this implies determinant of Ka will be equal to k to the power of n into determinant A. I can this is one of the formulae that you have to learn now. Any scalar multiplication. Why is it like this in determinants? Because for every matrix, so now I'm coming to one note point. Let me finish up the other problem also. So I'll come to determinant of 3 times A, and I shall multiply every element of this A by 3 and take out the determinant. So this is determinant of 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12 is equal to 12 3s are 36 minus 9 6 are 54. So what is 36 minus 54? Minus 54 plus 36, 14 minus 6 is 8, 4 minus 3 is 1. And you have got it as minus 18. This is equal to minus 18. Now let us do with the help of this formula. So I shall write determinant of 3A is equal to 3 power order is 2 into determinant of 1, 2, 3, 4 is equal to 3 square is 9. 9 into 4 minus 6 is minus 2, which is equal to minus 18. So once again we proved that this formula is right. It has been generalized, but why is it like this? So now I am coming to one note point. Okay, if A is equal to 1, 2, 3, 4, no, let me take it in a different way. I shall take it as 2, 6 minus 4, 2, something like this. Okay, so now here if I take out something common, taking out 2 common, from a matrix. You know how we should take out the common? Because when I am multiplying, when I am doing scalar multiplication 2 times here, what did I do? I multiplied every element of the matrix by 2. So if I have to remove common also, the same procedure ulta I have to do. So it will be what? If a is equal to 2, 6 minus 4, 2, and I have to remove. We see that every element is a multiple of 2. I will pull out 2 as the common. Then you will be getting 2 into, this will become 1, this will become 3, this will become minus 2, and this becomes 1. This is taking out common from a matrix, where all the elements of the matrix should be a multiple of one particular number. Then you can remove that as the common from all the elements of the matrix. But then this is a note point, very important note point from a matrix. So this is matrix A. Now I am going to a determinant of A. If I am giving this notion, this denotion as determinant of 2, 6, so this will be delta A equal to 2, 6 minus 4, 2. If you have to remove common, then you cannot remove common from all the elements, but instead you have to remove common from every row or every column. Okay, and you cannot remove common from one row and one column. Instead you have to do, see, you have to take out, in this I'll take out 2 common. It will be 2 into determinant of 1, 3 minus 4, 2. You got me? See, when you are taking out common from a determinant, every row you should be taking out 1 common. And after taking out 1 row, you cannot take out 1 column, you cannot take out. Either you can take out C1 and C2, 2 common elements, or you can take out R1 and R2, 1 column, 1 element. So see, 1, 3, I have taken out, say, out of 2, 6, I have taken out 2 common. Now out of these 2, another 2 I can take out. Already 2 is there. Now out of these 2, I shall take out another 2 common. Then this becomes 1, 3 minus 2, 1. So this is equal to 4 times determinant of 1, 3 minus 2, 1. Okay, so this is the way you take out common from the determinant. That is how, here, come back here. If I am having Ka, how many rows are there? How many rows are there? That many K's will come out as common. That is the reason we have K power n into determinant A. See, if I take out the determinant of this, then I should take out 2 common here also, 2 common here also. It will become 2 power 2, 2 power the order into determinant A. Now this is the reason that we get this formula as K power n into determinant A when there is a scalar multiplication for a matrix. And if you want to take out the determinant, every row you have to take out. So this is also equal to, delta A is also equal to, okay, I shall remove common from column number 1. See, from here if you take out column number 1, if you take out 2 common, then this becomes 1 minus 2, 6, 2. And once again from this column also I will take out another 2 common. This will be 2 into 1, 3 minus 2, 1. Okay, we get the same thing. So either you can remove from both the columns or from all the 3 columns, or you can remove common from all the 3 rows, but 1 row and 1 column is not allowed. And when you are taking out this, so the major difference between the matrix and the determinant is in the scalar multiplication or in the scalar taking out the common of a scalar from the determinant and a matrix. What? In matrix, all the elements should have something common to remove something as common. But in determinant is not so. Every row or every column can be removed with a common multiple, whatever you have inside. Okay, this was an important point. And after this, we shall go to our next problem, that is where we use this formula. We have like this. So I don't want you to use the regular method. Question number 3 tells like this: if A is equal to matrix 1, 2, 4, 2, then show that determinant of 2A is equal to 4 times determinant A. This is proving. And if they say find determinant of, so I shall include my own problem inside this. You have show that this is the sub question number 1. I shall take sub question number 1, find determinant of 3A. If it's like this, what do you do? So I shall use formula for this. Here I shall prove what they want. Okay, so I shall take LHS of the first sub question. LHS is equal to determinant of 2A is equal to determinant of 2 times multiplied with the matrix A. So go to the matrix A, multiply every element by 2. That will be 2, 4, 2 4s are 8, 2 2s are 4. I shall pull out the determinant. 4 2s are 8 minus 8 4s are 32, which will be minus 24. Okay, and now I shall do the RHS of that. Your RHS tells you did 4 times determinant A is equal to 4 times. Go to the A matrix, pull out the determinant, that will be 2 minus 4 2s are 8. It's equal to 4 into 2 minus 8 is minus 6, which is equal to minus 24. So you see that LHS is equal to RHS, and we have proved that determinant of 2 times A, therefore determinants of 2 times A is equal to 4 times determinant A, which is nothing but 2 to the power of number of the order of the matrix, which is 2 into determinant A. It's one and the same. So now let's go to the sub question number 2, and I shall directly find out determinant of 3A is equal to 3 power order. What is the order of the matrix? Square into determinant A. So this is equal to 9 into, I shall pull out the determinant, 2 1s are 2 minus 4 2s are 8, which is equal to 9 into 2 minus 8 is minus 6. So you got minus 54. Okay, so now like this you can find so many interesting properties on determinants, and now I shall tell you how to take out something called as minor and cofactor of a determinant. Okay, and even before that, let us do few problems from the same exercise to find out the determinant of a third order matrix. And if you are thorough with this, and I want you to make your own matrices of third order and take out its determinant, you should get used to the method. Then it will be easy for us to continue with the determinant properties, where every property I have to do some multiplication and expansion of the determinant. So here goes the few problems of evaluate determinant. See, question number 5, you have evaluate the determinant. In that, the first problem is determinant of 3 minus 1 minus 2, 0 0 minus 1, 3 minus 5 0. It's damn simple because plenty of zeros are there. Next, 3 minus 4 5, 1 1 minus 2, 2 3 1. Okay, you have the determinant like this, and there are other determinants also, and I want you to learn this very quickly, children. Now coming to the first problem, I shall say delta is equal to, and now every time let us take out the determinant using row number 1 constantly. Every time consistently we shall be taking only row number 1, the expansion along row number 1, though we know that the determinant can be taken out in any kind, in any row or any column. So let us try to find out through row number 1 only. So row number 1, 3 into, wherever 3 is there, that particular row, that particular column and row you delete, the remaining you pull out the determinant. It is 0 minus 5 into minus 1 is 5, so 5. And then the next element I'll take with the opposite sign, minus 1 I shall write as plus 1, and then wherever 1 is present, that column and that row I shall delete. So these 4 I'll take, 0 minus 3 into minus 1 is minus 3, so plus 3. Then minus 2 into 0 minus 0 is 0 is equal to 3 into minus 5 is minus 15, 0 plus 3 is 3 into 1 is 3, minus 0 is equal to minus 15 plus 3 is minus 12. This is the way you expand. And you know, whenever there is a fourth order determinant in JEE examination, sometimes they give you fourth order determinant, then you should expand the determinant along the row or the column which is having maximum number of zeros. So this is one particular problem where you can see that row number 2 is having 2 zeros and only one element is present. So this can also be found out, delta is equal to, along row number 2, 0 0 you forget, this place will have negative sign, so minus 1 I shall write plus 1, and 1 wherever it is present you take out that row and that column, the remaining will be minus 3 into minus 5 is minus 15, minus 3 into minus 1 is minus 3 plus 3. So you got minus 15 plus 3 as minus 12. See, we got the same answer. Now this I only wanted to show you that the determinant can be expanded and very quick if it is expanded along the row or the column which is having more number of zeros. But let us standardly expand always along row number 1, so there are no errors. Okay, there should be no errors at all, no silly mistakes. Silly mistakes are very dangerous. So now I'll come to the sub question number 2. Delta is equal to now I shall take along row number 1, 3 into something, minus 4 I shall write plus 4 into something, plus 5 into something. Okay, along row number 1. And now go to the 3, wherever it is, that row and that column you delete, pull out the determinant. This should become a habit. This number, then use these 4 elements. This will be 1 plus 6. Next I have taken minus 4 as plus 4, so you should take these 4 elements. So it will be 1 plus 4. Next 5 is here, so you should take these 4 elements. It will be 3 minus 2. So this is equal to 6 plus 1, 7 3s are 21, 4 plus 1, 5 4s are 20, 3 minus 2 is 1, 1 plus 5 is 5. So this is equal to 1 plus 0 plus 5 is 5, 2 plus 2 is 4, the answer is 45. 1 plus 5 is 6, 46 is the answer. So 46. Now this is the way you will expand the determinant. Now these third order determinants have to be practiced well. You should be doing several problems on this, so that you are very quick enough to find out the determinant. It should be done in few seconds. And there are certain 1 marker and 2 marker problems where they give you 2 determinants and ask you to they be equated, and you will have to find out some unknown variable value. So let us see. So they have given question number 7. They say find x. In that, sub question number 1 is determinant of 2 4 5 1 is equal to determinant of 2x4 6x. There is one another. Second one is determinant of 2 3 4 5 is equal to determinant of x3 5 no 2x5 2x5. And then there is one another, that is 8th question. You have determinant of x2 18x is equal to determinant of 6 to 18 6. Then what is x equal to? You have whenever you take out the determinant value as good as your modulus. Inside the determinant value, if you have an unknown value, whenever you take out determinant, the opposite side you will always take plus or minus. Please remember this. Determinant property, one of the properties is as good as your property of your modulus. Inside the modulus, like for example, I'll tell you determinant of minus 3. Okay, sorry, the modulus of minus 3 is equal to plus 3. Modulus of plus 3 is also equal to 3. This I know when I have a real value inside. But if you have modulus of kx, this we do not know, children. If I have modulus of k is equal to 9, okay, so modulus of k is equal to k square, let me say. So k square is equal to modulus, whenever I remove k square, if I remove, it will always be equal to plus or minus. Similarly, this k is equal to 9 implies k is equal to plus or minus 9. It may be plus 9 or it may be minus 9. I don't know what is this inside. So, okay, so whenever you remove modulus, you are going to put plus or minus in the other side. So, the same property holds good for determinants also. Inside the determinant, if you have unknown value x or k like this, on the opposite side, if you have certain real value, you are going to take it as plus or minus. So, now here 2 5 4s are 20 minus 20 is equal to 2x into x is 2x square, 6 4s are minus 24. 2 minus 20 is minus 18, and minus 24 brought this side is plus 24 is equal to 2x square. 24 minus 18 is 6 by 2 is equal to x square. So x is equal to plus or minus 3. No, plus or minus root 3. So always you have to take plus or minus if you have square, or if you have modulus, or if you have determinant value. So now here you have 5 2s. So what they have given. One more thing is, just because they are equated, you cannot equate the corresponding elements. See, if I give you this matrix is equal to this matrix, the first, second, third and fourth element can be equated. We have already done such kind of problems also where we found out A, B, C, D or X, Y, Z, T values, is it not? So if it is matrices, you can just equate the elements, the corresponding elements, the corresponding places, elements you can equate. But when it comes to vertical lines given there, be careful that you have to be sure that you are going to take out the determinant. So I shall take out the determinant here. 5 2s are 10 minus 12 is equal to 5x minus 3 2s are 6x. It's equal to 5x minus 6x is minus x, 10 minus 12 is minus 2, so you got x is equal to 2. And then here, x square minus 18 2s are 36 is equal to 36 minus 36, 36 is gone, so you got x square is equal to 36, x is equal to plus or minus 3. And yeah, I told you that whenever you remove determinant, the opposite side you have to take plus or minus. Now that has not come in these three problems. We have got x square, you have square on the top. So that was a note point for you to remember that whenever there is a unknown value inside the determinant, and if you remove the determinant, opposite side you have to take plus or minus. Of course, in the same chapter we are going to learn something called as area of triangle and equation of the line. We will be using that property. Okay, so now I want you to learn something about minor and cofactor even before we go to the properties of determinants. Let us see something about minor and cofactor. So this has been completely theory for you. Please understand what is minor and cofactor. That's also a part of theory. Once we are done with the theory things of this determinant, the problems are amazing. We can enjoy. Okay, so now we are coming to something called as what is this minor and what is this cofactor. A part of this is already learned. So when I am telling, you will be relating to it. What you have already learned. What is this minor? So minor is denoted by M and cofactor is denoted by A. So this I will say Mij and this I will say Aij. So what do you mean by this Mij? Mij is minor of the element Aij is obtained is the value of the determinant obtained after deleting ith row and jth column. Okay, after deleting ith row and jth column. And I shall tell you about this cofactor also. Okay, so cofactor, okay, and jth column and is denoted as what? Mij. So you know what is minor. Minor you have already learnt till now. What? If I want minor of 2, wherever 2 is present, that row and that column you delete, you will get the minor. And they expand the determinant, you will get the minor. Okay. So now what is cofactor? Cofactor is cofactor of an element. Aij, it is given by this formula. You know what? Minus 1 to the power of I plus j, which we already learnt as the sign convention. So take that sign and multiply that by the minor. This is a formula for Mij. And what is this cofactor denoted by? Aij. So this is nothing but Aij. So this is the cofactor formula. Aij is equal to minus 1 raised to the power of I plus j into Mij. So what is the difference between minor and cofactor? It only differs with the sign. Now I shall give you one example here. So I shall take A is equal to 1 0 minus 1, 1 2 1, 2 2 3, something like this. I have taken a matrix. I have taken a matrix now, and I want minor of 2. I want cofactor of this 2. Let me take all as different elements. Okay, so I'll take 1 minus 1, Here I shall take 5, this I shall take 6, this I shall take 4, this I take 7. Okay, so now all the elements are different. So I want minor of 3 and I want cofactor of 3. I want minor of 7 and I want cofactor of 7. Let us try to find out. So I will say minor of minus 1. Minus 1 is in which place? Plus minus plus. This is in the place of A11, A12. This is in place of A13. Minor of minus 1 is equal to, so this I will write M13. So what do you mean by M13? Minor of the element present in first row and third column. That is A13 is minor. A13 is this one. I want minor of minus 1. How do you find out minor of minus 1? You delete the first row and the third column and remaining elements you take out the determinant. That's what we have been doing when I have taken the determinant. What I'll do? Minus 1 is present in this place. Wherever minus 1 is, that row and that column you delete. So this will be equal to determinant of 5247. 5247 is equal to 7 5s are 35 minus 8. So this will be equal to 27. Okay, so now I want cofactor, that is A13. I want A13. So how do I take out A13? Cofactor, how do I take out? So this will be cofactor of minus 1. Minus 1. That particular place is having plus or minus? It is having plus. How do you find out? Using this formula. Minus 1 raised to the power of 1 plus 3 into M13 is equal to 3 plus 1 is 4. 4 times minus multiplied will give you plus, and M13 plus 27. So you see that M13 and A13 both are same. So there is only a difference of sign between minor and cofactor. So now let me take out, I shall take out minor and cofactor of 7. Okay, so I shall say M32, is it not? It is in third row, second column. So I am telling M32. So what is this M32? M32 is that particular third row and second column you delete, the rest is the determinant value. So this will be equal to 1, determinant of 1 minus 1, and if you delete this it will be 5 6. 5 6 is equal to 6 ones are 6 plus 5, which is equal to 11. And now what is A32? This is minor and this is cofactor. Now what is A32? A32, third row, second column, 3 plus 2, it is giving you odd number. Minus multiplied odd number times will give you minus. Minus into M32. M32 is 11. Okay, so this is cofactor of, this is cofactor of 7 in this matrix, and this is minor of 7. Minor of 7. So how do you take out minor? Whichever element minor you want, that particular, wherever that element is present, that particular row and that particular column you are going to delete, and the remaining elements take out the determinant, you get the minor, and that minor multiplied by that place sign will always give you the cofactor. So minor and cofactor have the difference of only the sign. This is about minor and cofactor. Now all the cofactors can be put into one matrix, and that is called as matrix of cofactors. Okay, so I want you to find out the matrix of cofactors. Let's come to matrix of cofactors. Okay, so for one matrix, take out all the cofactors and put it in the matrix. Then we'll have a matrix A and its cofactor matrix. So I shall take some simple example which is in your book itself. You have one delta which is given by, no, I shall take it as a matrix. A is equal to 2 minus 3 5 6 0 4 1 5 minus 7, and I want the cofactors of all these elements, and I want the cofactors of all these elements put into a matrix, and that's called as matrix of this cofactors. So I want matrix of cofactors of A matrix. Let us start finding out. See, when I am taking out the cofactor of A, I should be multiplying by plus. When I am taking out the cofactor of minus 3, I should be multiplying by minus, and the corresponding determinant I should multiply. So I shall do this in detail. See, I shall say A11, A11, 1 plus 1, 2. So it will have plus, and it is determinant of first row, first column. This will be A11 will be cofactor of 2. 2 wherever is present, remove that and the determinant value you take. This will be 0, 4, 0, 4, 5 minus 7 is equal to what? So it will be 0 minus 20, which is equal to minus 20. Next I will go to A12. A12 is the cofactor of the element present in first row and second column. So I will delete first row and second column. First row, second column, then you will get these 4. So, and A12, 1 plus 2 is 3. 3 is an odd number, so you will have minus determinant of, which all you have to take? First row, second column. First row, second column you delete, you get these 4. So it is 6, 4, 1 minus 7 is equal to minus of 6 into minus 7 is minus 42 minus 4. Minus 42 minus 4 is minus 46, into minus will give you plus 46. Okay, so now A13. So now like this, I shall not write the determinant, instead I shall take directly. So please follow me. A13, A13 is this. So that particular row and column I will delete, I shall take out the determinant. 6 5 is a 30 minus 0 is equal to 30 minus 0 is 30. Next I want A21, 2 plus 1 odd number, so minus, and wherever this 6 is present, that column and that row I will delete. I have to pull out the determinant of this much, minus 3, 5 and 5 minus 7. So it is minus of 7 into 3, 21 minus 25 is equal to minus of 21 minus 25 is minus 4, which is equal to plus 4. Next I will come to A22. So A12, A13, so A11, 12, 13, 21, 22. 22 is this one. That is, okay, just because the number is 0, that doesn't mean that it does not have its minor cofactor which is 0. It has its own minor, its own cofactor. Okay, so now let us take A22. Wherever 0 is present, that particular row and column I will delete and take out this determinant. And 2 plus 2 is even number, so it will have plus into, I shall pull out the determinant of these 4 elements. It will be minus 14 and minus 5, which is equal to minus 19. Now this is the way you take out the cofactors of all the elements, and all these elements can be, I shall do A23 also. A23, that is 2 rows I will be completing. A23 will be equal to, this place will have minus, so minus, or 2 plus 3 5, odd number minus, or it is like this place is having minus. Anyway you can learn. And then wherever that second row and third column I will delete, the remaining I should do, it will be minus of 10 plus 3, which is equal to 13. Okay, minus 13. Now these are the cofactors. So therefore cofactor matrix or matrix of cofactors of A, which is equal to the first cofactor is minus 20, the second cofactor is 46, the next is 30, and the next is 4, next is minus 19, and the next is minus 30. Okay, now the remaining I will do directly. So next I want cofactor of 1. This place will have plus, so neglect this row and this column, then it will be minus 12. So this is minus 12. Next this place will have minus, so I shall take minus here first of all, and wherever 5 is, that column and that row I will delete. Then I will have 2 4s are 8 minus 6 5s are 30. 8 minus 30 is minus 28, so this will become plus 28. And the next I shall take third, the last element, which is A33. 3 plus 3 is 6, this place will have plus, so nothing to write there. And wherever this element is present, that column and that row I am deleting. It is 0 plus 18, so I have got 18. I have got 18. Now I will show you something amazing. Now I have got the cofactors of all the elements, is it not? I will use row number 1 of this matrix and row number 1 of the cofactor matrix. I will multiply the corresponding elements and we will add. See, you have 2 2 into, I am just doing a procedure and then I'll tell you what I am doing. 2 into minus 20, then minus 3 into 46, and then plus 5 into 30. What does this give you? This will be equal to minus 40 minus 3 6 are 18, 3 4s are 12, 138 plus 150. How much does this give you? I shall just calculate. This will give you 138 plus 40 is equal to 178 minus 150 is equal to 28. So this is equal to minus 28. Okay, 150 minus 170 something you have got 28. Now what I have done is delta A or determinant A. What I have done is I have used first row element and I have multiplied by all the cofactors of the corresponding cofactors and I have added. Now I shall do this magic with the other thing also. So I shall say this was along row number 1. I am naming it as delta A. Let us find out. So next I will say again delta A. This will be along R3. Suppose, okay, I will be using R3. See, I shall use row number 3 here and row number 3 here. Okay, this and this will use. You have 1 into minus 12. 1 into minus 12 plus 5 into 28 minus 7 into 18 is equal to, so I have minus 12, then you have 28 into 5 which is equal to plus 140 minus 18 into 7 is equal to 126. How much is this equal to? This will be 126 plus 12 is equal to 138 minus 140 which is equal to minus 2. Something has gone wrong here. Okay, let us check out R3, row number 3 and row number 3 cofactors. 1 into minus 12 is minus 12, then you have 5 into 28, then you have minus 7 into 18. So let me check the cofactors. You have one cofactor of 1 is minus 12, minus 0, yeah, minus 12, and cofactor of 5 is 4 2s are 8, 8 minus, here I have gone wrong, 4 2s are 8 minus 30, 8 minus 30 is 22, and then cofactor of minus 7 is 0 plus 18 is 18. Okay, now let me go. I have multiplied here. I had gone wrong with this 28. This was 22. So this will be 110, is it not? 5 2s are 10, 10 plus 1. So what does this give you now? You have 12 plus 126 is equal to 30. 12 plus 126 is equal to 138 minus 1110 is equal to, okay, you got again minus 28. Isn't this amazing? See, without making mistakes, if you take out all the cofactors. So now what I have done is pulled out the determinant using rows, any row or the corresponding cofactors. Now see, I shall do along C2. I shall do along column number 2. I shall use column number 2 elements in this column number 2 and in this column number 2. So I shall take this column and this column. Minus 3, I shall take minus 3. Delta A is equal to again minus 3 into 46. Then plus 0, 0 into anything is 0, forget. Then you have plus 5 into its cofactor is 22 is equal to, okay, let us check it out. So now again you have 46 into 3 will be equal to minus 138 plus 110. 110 is equal to minus 28. So this is the way we are getting a determinant value when we are multiplying any row elements by their own cofactors. You will always end up getting the determinant value. This was the regular determinant value what we learned today. So now today children, your job is to use your own small numbers and find out the determinant of third order matrices. Take a third order matrix, do plenty of determinant values, and then these determinant values have their own properties. We are going to learn about all these properties. Today you have learnt that in a matrix, I can take out all the minors, I can take out all the cofactors. Here in this example I have taken out only the cofactors. All the cofactors put in orderly in another matrix, then this is called as matrix of cofactors of this A. And here the special property is any row or any column multiplied by their corresponding cofactors, we always get the determinant value. Under expansion of determinants, you have two properties. So we shall figure out what is exactly the other property in the next class, because I shall repeat this explanation with another small example where I can take out the cofactors once again, and we shall see the two properties under expansion of determinants. Now I shall give you one more I shall tell you once again in the sentence form this property whatever we learned till now. Okay, so please make a note of this note, and of course it's a property which we are learning. Please make a note of today's what you have learned. Any elements of any row. Okay, any row, let me write like this, elements of any row or any column multiplied by their own cofactors. This own is important. By their own cofactors and added gives the determinant of a matrix. Gives the determinant of A. Okay, determinant of matrix A. Of matrix A. This is one of the main things what you have learned today. Okay, so now I shall show you one matrix. I shall write a matrix. I'll take out the determinant of that so that you recall how we had done in a standard way. So I shall take some matrix over here. See, they have given A is equal to 1 1 1 1 2 minus 3, then you have 2 minus 1 3, and I shall give you another one. A is equal to 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. Okay, there are two matrices, and I don't want you to forget this. Learn to take out the determinant always along row number 1. So I'll go to row number 1. So I shall say determinant A or delta A is equal to row number 1. 1 I shall write as it is. Use these 4 elements. It will be 3, 2 3s are 6, minus 1 into minus 3 is 3. I shall write this with the opposite sign, minus 1 into, so this will be 3 minus 2 into minus 3 is minus 6, so this will becomes plus 6. Then plus 1 into, this will be minus 1 minus 4. So this is equal to 6 minus 3, 3 ones are 3, then 6 plus 3 is 9, 9 into minus 1 is minus 9, minus 1 minus 4 is minus 5, so this is minus 5. So what is the answer? 9 plus 5 is 14, minus 14 plus 3 will be minus 11. This is the way you take out the determinant, and this determinant is obtained by multiplying the first row with their cofactors. That is what we are doing here. So that was the property I told you. Again here I shall say delta A is equal to 2 into 2 is having plus value, is it not? So I shall put plus there, and I shall take out the cofactor, that is plus into determinant of this much, it is 4 minus 1. Next this I shall take, the element is minus 1, but when I am taking cofactor I should write its opposite sign. So I shall write plus 1 row number 1. Wherever it is present, that column, that row you delete. I will take out the determinant of this much. 2 into minus 1 is minus 2 minus 1 into minus 1 is minus 1, it will be plus 1. Next, similarly go to the next element, plus 1 into minus 1 into 1 is 1 minus 2. So it's equal to 4 minus 1 is 3, 3 2s are 6. 1 minus 2 is minus 1 into plus 1 is minus 1. 1 minus 2 is minus 1 into plus 1 is minus 1. 6 minus 2 is 4 is the determinant value. Now this is the way you take out the determinant. So regarding with the properties of this determinants, so we have one more theory class. The next class will be full of properties. Then our class will be like using all these properties to do so many problems. Okay, see you in the next class. So even before I meet you in the next class, I want you to practice with the third order determinant numerical problems. Take out the determinant of many determinants where you can have your own numbers. Put your own numbers and pull out the determinant.